A modern city today could not exist without water. For where there is water, there is life. Without it, there is nothing. In the cities of Australia, the driest continent in the world, the people do not think much about water. They know that when it's needed for industrial or domestic purposes, or even for gardens, there is always ample water available for use merely by turning on a tap. Huge storage reservoirs provide an ever-ready supply of life-giving water even in the driest months. Moisture to keep gardens alive and produce such living beauty as this. In the large irrigation areas of this country, engineers have brought life-giving water to an area which at one time was practically desert country. Here water, fed through the irrigation channels, can be turned on and off as required by these measuring wheels. Like the city dweller, the man on the land in the irrigation areas can water his garden whenever it is required. Where water is readily available, the good earth can be made to yield up its bountiful harvest. But what of the huge areas of this country where there is no irrigation and no great storage reservoirs? Here the man on the land relies entirely on the annual rainfall to make his pastures grow. And rainfall cannot be turned on and off like a tap. The fluctuation of rainfall over so much of Australia has been a problem to primary producers ever since the land was first settled. Here at the Sydney University McGarvie Smith Animal Husbandry Farm at Badgery's Creek, Mr. H.J. Geddes, the officer in charge, has shown the way in the development of an economic, self-contained irrigation system. This system depends upon collecting all the water run off from a property into suitable dams and using it to irrigate pastures and crops by means of a portable sprinkler system. The farm's annual rainfall has averaged a little over 25 inches a year, but the seasonal distribution has been extremely irregular. These graphs show how the average yearly rainfall pattern bears no relationship to any one year. The seasonal distribution shows how the rainfall has varied from year to year. The only constant feature of the rainfall is the tendency to get two heavy falls annually, but these can occur at any time, as the records show. Although it is in the oldest farmed region in Australia, the variability of the rainfall and the difficult nature of the soil have always prevented the establishment of improved pastures on any permanent basis. The topography of the farm resembles the back of a hand, with the fingers representing the spurs running towards Badgery's Creek, and the spaces between the fingers representing the valleys. The gently undulating nature of the country lends itself very well to the project. It is not difficult to find suitable sites for dams in which a large storage of water is obtained for each cubic yard of excavation. Most of the storage dams built on the farm for irrigation purposes store 5 or 6 cubic yards of water for each cubic yard of excavation. There are 12 dams on the farm holding 48 million gallons of water, which is sufficient to see the farm through a 12-month drought. The soil is a heavy clay with a surface layer of naturally poor grey soil up to a foot in depth. It responds to phosphate and molybdenum, but no fertilizers are of much avail when moisture is lacking, as is so often the case. The first experimental paddock irrigated from a farm dam proved so successful that it was decided to investigate further the possibilities of irrigation. But as bores were too salty and nearby creeks ran too infrequently, the only practical supply of water was the runoff from the farm when it rained. The first irrigation dam was then built. It was constructed by contract at current rates and cost £250. 6,000 cubic yards of earth were moved, giving the dam a capacity of 6 million gallons, a storage of 6 cubic yards of water for each cubic yard of excavation. The heavy subsoil, which makes cultivation difficult in this area, is an advantage when building dams, as little trouble has been experienced with seepage or tunneling. The storage costs at Badgery's Creek were probably lower than usual due to the favorable conditions, but water for irrigation must be obtained cheaply. By a system of contour drains, all the runoff water from the farm is fed into the various dams when it rains. The farm has been progressively developed as a watershed, and now the entire area of 400 acres has been drained and the water stored for irrigation. In fact, the returns obtained from irrigation on the farm have been so substantial that a lot more could have been spent on water storage and still have left the farm on the right side of the ledger. On rolling country, the cheapest form of water storage is a dam. On flat country, economical storage can be obtained with a turkey nest tank. The turkey nest tank at the farm has been built on flat country near the bank of a stormwater creek. It is 150 yards in diameter and holds 8 million gallons of water. It is not dependent on any runoff water from the farm, but is filled from the stormwater creek when it runs after rain. The bank of the turkey nest tank has a batter or slope of 3-to-1 inside the dam and 2-to-1 on the outside. With modern equipment, the irrigation of large areas of pasture with a minimum of labor is now possible. Sprinkler systems are available to meet all sorts of conditions, and the emphasis today is on portability. Lightweight aluminium pipes are used, and when fitted to skids or wheels, can be moved around a property quite easily. Pipelines can be quickly coupled together, and when the water is turned on, the pastures receive their predetermined amount of moisture. These sprays deliver the equivalent of 30 points of rain per hour, rain which can be turned off and on as required. By using a sprinkler irrigation system at the farm, it has been found possible to achieve the equivalent of regular rainfall throughout the year with spectacular results. The technique of water harvesting proves that water and fertilizer together make it possible now for highly productive pastures to be grown almost anywhere. Another scheme for making better use of an irregular rainfall is the Keyline Plan. The Keyline system depends upon deeply ripping the hillsides parallel with a keyline or off-contour, so that the runoff water is absorbed mainly where it falls instead of draining away. Dams are located on the keyline so that any surplus water will be collected. The dams have pipes through their banks, so that the water can be let out on the contour for gravity irrigation. It is claimed that the off-contour ripping, which is the main feature of the keyline system, drifts the water out of the center of the valley to the spurs and bridges. The work at Badgery's Creek has shown what irrigation can do on soil that has always been regarded as extremely poor. Soil poverty is no longer a barrier to the development of highly productive pastures. This one-time poor farming country, one of the oldest cultivated regions in Australia, remember, has now been turned into an area of green, lush pastures by means of an irrigation system using water which previously had run to waste. Pastures that bring new life to old land. The Badgery's Creek project is a living example of what the scientist is doing to give Australia greater production. The system of irrigating farmlands from storage dams has been established, and the application of the system to all suitable areas is up to the individual. Conserving every drop of water which falls upon the land is the natural means of improving it, of enabling the land to support its flocks with assured feed throughout the year. The principle of using water where it falls by collecting the runoff from a property when it rains and distributing it by an irrigation system has been proved both economic and sound. For water harvesting in areas where there is reasonable rainfall means that water can be provided when it's required to do the most good by merely turning on a tap. The project, initiated by Mr. Geddes, has opened a new vista in the efficient development and use of the water resources of this country. Making the best use of water is of vital importance to the future of Australia. And so, the foresight, planning and effort of one man have finally borne fruit. A symbol for the future. A lamb in lush pasture. A good omen for the future of a country that is learning to conserve its precious water, the lifeblood of a nation.